In question 7, we're asked to show that the random telegraph signal is a strict sense stationary process. And to show a process is strict sense stationary, we basically need to prove that a shift value on the time axis will not affect the statistics of this process. So that is to say, we need to prove this here. So the probability for y of tn to equal yn, y tn minus 1 equal yn minus 1, after putting a shift value epsilon on the time axis, and for all these states to remain the same, the probability should also remain the same for a strict sense stationary process. And that has to hold true for any n, t1, t2, all the way to tn and epsilon. And from learning the random telegraph signal, we see that, let's remember we used a hyperbolic function to represent the probability. And here we have that, for one state to equal 1, given its past state is 1, we can represent the probability as such. So e to the power of minus lambda, and the difference between those two values, the t timestamps, and then there's this hyperbolic function, and then lambda difference between the two timestamps, right? Because we're going to make use of this later. And now we can write the joint probability by dividing this joint probability into several conditional probabilities, just like how we did in the last assignment for that Markov chain problem. So eventually we can have this. So pretty much this is a group of conditional probabilities. The probability of ytn is 1 given its past state, y of tn minus 1 equals something given its past state, all the way to probability of y of t2 is something given y of t1 is something, times eventually p of y of t1 equals something. And the last probability would be 1/2, because this is a random telegraph signal and it starts at 1 or minus 1 with equal probability. And the rest conditional probabilities can all be written as the difference between the two timestamps. So pretty much everything can be written as e to the power of minus lambda tn minus lambda. This hyperbolic function tn minus 1 all the way to 1/2. And we can see that a general shift on the time axis will eventually get canceled out, because when tn minus 1, the extra epsilon will be canceled. So here we have proved that a random telegraph signal is a strict sense stationary process.